Hello everyone, welcome to my channel. In this video, we are going to break down the UGC NET Computer Science previous paper of the year 2005 June paper 2. So there are actually 50 questions in this paper, but we will cover first 25 questions in part 1 and the remaining 25 questions in part 2. I will explain the concept in simple terms and provide tips and tricks to help you ace the exam. So whether you are a beginner or an experienced one, this video is for you. So let's get into this topic. Which of the following is not true? So here in the options they have given the power of the deterministic push-down automata is equivalent to, that is a DPDA is equivalent to non-deterministic push-down automata, and deterministic Turing machine is equivalent to non-deterministic Turing machine, and power of deterministic automata, finite automata, is equivalent to non-deterministic finite automata. So which of the given three options are not true? That means we have to find out that which of them is false. Okay, so which of the given options is false? The power of a deterministic push-down automata is equivalent to the power of a non-deterministic push-down automata. So this is not true. Why this is not true? So here the non-deterministic push-down automata is having more power than the deterministic push-down automata. So that's why. So the option B is correct. So this option is not true. So the equivalence of the deterministic push-down automata and the non-deterministic push-down automata are not equivalent here. So the option is B. Next, identify the language which is not context free. So here they have given the option L equals to W power R, where W belongs to a combination of 0 and 1, and B is L equals to A power n, B power n greater than or equals to 0, and L equals to WW, where W belongs to a set of combination of the strings 0 and 1, and option D is L equals to A power n, B power n, C power n, D power n. So here n comma m values are greater than or equal to 0. So here we will check each option one by one. So option A, L equals to W power of W belongs to 0 comma 1 whole star. That means, so here the W is a combination of 0 and 1 number. Okay. So here W power of, that means it represents strings where the W is followed by a reverse of the W. Okay. Suppose, so we have 0 and 1, 0 plus 1 whole star, then W power R will be 1 plus 0 whole star. That is the reverse of this combination. And this type of language is not context free, because context free grammars enforce the symmetry required to reverse W. So this requires a comparison between the two halves of the string, which is beyond the capability of a push-down automata. So that's why this option is not true. So it is a false. So it is not context free. Next, option B, L equals to A power n, B power n, so where n greater than or equals to 0. So this is an example of the context free language. A push-down automata can recognize it by pushing number of A's onto the stack and popping them when encountering B's. So this is an example of the context free language. And option C, L equals to WW, so where W is a combination of 0 and 1. Okay. So this language contains strings where the second half is identical to the first half. So if you suppose we are taking a 0 plus 1 whole star and 0 plus 1 whole star into 0 plus 1 whole star. And this one is also not context free, because a push-down automata cannot compare two strings of arbitrary length for equality. Next one, option D, L equals to A power n, b power m, c power n, d power m, where n and m values are greater than or equal to 0. This language requires matching a power n with b power n and b power m with c power m, which involves multiple dependencies here. And it is not context-free language because the context-free grammars can handle two simultaneous dependencies. So that is n and m. So it can't handle two different dependencies. So it doesn't support such amount of memory. So it requires a lot of memory to compare two strings. Okay. So that's why the correct option is option D. So which is a context-free language. So option D is a context-free language, and A, C and D are not context-free language. Okay. So option D is the context-free language. So A, C and D are not context-free language. Next. The transitive closure of a relation R on set A whose relation matrix is. So given that it is a transitive closure. Transitive closure means so it follows a property, that is if A comma B and B comma C follows, then the relation must satisfy A comma C also. So that is a transitive property actually. So we can find out the transitive closure in that way, or we can easily find out the transitive closure by multiplying the matrix with itself. So we are multiplying the matrix with itself. Okay. So then if you multiply these two matrices, then we will get the answer, that is 1, 1, 1, 1, 1, 1 and 1, 1, 1. So in this manner we will get the matrix. Okay. So this is the transitive closure of this matrix. So the option is C. Correct option is C. So here we can find out the transitive closure either by following the property, that is if A follows B and B follows C, then A must follow C. So this property must be taken, or we can compute the transitive closure by using the Warshall's algorithm by repeatedly multiplying the matrix with itself and checking for paths. So the correct option is option C. Next one. Consider the relation on the set of non-negative integers defined by x equivalent to y if and only if. So given that x is equivalent to y, so we have to satisfy the equivalence relation here. So what is the equivalence relation? So equivalence relation means, so the given option must satisfy, it must be reflexive, symmetric and transitive. So it has to satisfy these three properties. Okay. So in the given options, if we check, so option C satisfies all these three relations. So let us check this one. So here x comma y, x mod 3 equals to y mod 3, that is the option C. So we are considering x value as 4 and y value is 7. So if you perform the operation here, we get the same value, that is 1. So here the 4 comma 7 is the set. So we have to consider this relation 4 comma 7, and we have to find out whether it will satisfy this property or not, reflexive property, symmetric property and transitive property or not. Okay. So we are applying the option onto the reflexive one. So reflexive means the same one will repeat, that is x mod 3 equals to x mod 3. And symmetric, so symmetric means, so here x mod 3 equals to y mod 3, then y mod 3 equals to x mod 3. Symmetric means the reverse, right? So reverse of the given relation. Next, transitive. So transitive means if A comma B follows, then B comma C, then these two sets will follow the A comma C. So in the same way, so x mod 3 equals to y mod 3 and y mod 3 equals to z mod 3, then x mod 3 must be equal to z mod 3. So it will satisfy these three relations. That's why the option C is the correct option. Next one. Minimum number of individual shoes to be picked up from a dark room containing 10 pairs of shoes, if we have to get at least one proper pair. So in a room there are 10 pairs of shoes. That means there are 20 shoes here. So from the 20 shoes we have to draw at least one proper pair. Suppose if I am drawing 10 shoes from the given 20 number of shoes, that is 10 pairs of shoes. So I am drawing 10 shoes here. Okay, but even I didn't find out the equal proper pair of shoes. So then I will draw another chance, that is a +1. So I will draw another shoe here. Okay, so this is the minimum chance of getting a pair of shoes. Right. So here each pair consists of a left shoe and a right shoe. So in the worst case, you could pick up all the left shoes, that is 10 left shoes, or all right shoes, that is 10 right shoes. So total we have 20 shoes here, that is 10 left shoes and 10 right shoes. A pair forms the one left and one right shoe, right? So after drawing the 10 shoes, so the minimum number of so at least if you want to get a pair of shoe, then we have to draw another one shoe, that is the 11th shoe, ensuring that at least one left-right pair is formed. So in the worst case scenario, we have to pick all 10 left shoes first. Next shoe, that is the 11th shoe, must be a right shoe, forming a pair. Thus, 11 shoes are required to ensure at least one proper pair is obtained. So next one, 101011 base 2 equals to 53 base b. Then b is equals to. So here a binary number is given and a decimal number with the base b is given. So we have to find out the base b here. So we know that. So how do we write the values here? So it is the base 2. So 2 power 0, 2 power 1 plus 2 power 2, 2 power 3 plus 2 power 5. Okay. So this is the left hand side value. Next, and similarly we will write the right hand side value also. That is the so 5 into b power 1 plus 3 into b power 0. Okay, so b power 0 is 1. Okay, so 5b plus 3. And here 2 power 5 is 32 plus 8 plus 2 plus 1. So 10, 11, 32 plus 11, that is 43. 43 equals to 5b plus 3. So 5b equals to 40, right? So then b equals to 8. Okay, so the b value, the base value is 8. So correct option is option B. Next one. The logical expression x bar y z bar plus x bar y z plus x y z bar plus x y z reduces to dash. So here in the given expression, so we have to simplify this expression to a given option. So from the given value, so here the x dash y and x dash y are common. So we will take this common. So x dash y into z plus z dash plus, so here xy is common, right here both. So xy into z plus z dash. So we know that, so z plus z dash equals to 1. Right? So here both will become 1. So now x dash y plus xy. So here y is common. So y into x plus x dash plus x. That means 1. So y into 1 is y. So correct answer is C, option C. Next one. Which of the following logic has the maximum fan out? So from the given options, we have to find out which logic gate is having the maximum fan out. So these type of questions were asked many times in UGC NET. So based on they will give one logical gate here like CMOS, NMOS, ECL, and they will ask some questions on their properties. So let us solve this question here. So first of all, what is meant by a fan out? Fan out of a logic gate is the number of its output connections to other gates. So from the given options, CMOS have DC fan out that are generally have the higher fan out than it is likely to occur in the practical circuits. So that's why option D is the correct answer. So fan out depends on the output current capability and the input current requirements of the connected gates. So these are the properties of the given logical gates. Okay. So here the maximum fan out is having the CMOS is having the maximum fan out, and the minimum fan out is for NMOS. Okay. So they may ask questions like this also. So which logical gate is having the minimum fan out? And based on the properties also they will ask some questions. Next one. Identify the logical function performed by the circuit shown. So here 4 NOR gates are given. This is a combination of the NOR gates. So we have to find out the expression for the given logical circuit. So we know that for a NOR gate we have the, so for the first NOR gate, so x plus y whole dash. Right. So now consider this second NOR gate. So we have already known the input of y value here. So x value is x dash, right? That is a plus x dash, and y value is x plus y dash whole dash. So performing the NOR of these 2 elements. Next, for this gate, plus so we are performing the NOR of these 2 gates, plus x plus y dash x plus y whole dash plus y dash whole dash. So this is the output of this logical gate. So now let us solve this given expression here. So first x plus y whole dash plus x dash. So here we are considering this next logical gate also, right? So for this again whole complement will occur here. So now if we open the parenthesis, first parenthesis here, so it will be x plus y whole dash plus, so we are opening the first parenthesis here, this one, plus x whole dash, double complement, plus, so here the plus will become product, and x plus y whole dash plus y whole double dash. So here double complement will become get cancelled here. Now x plus y whole dash so now x plus y whole dash plus x and x plus y whole dash plus y. So now if you open the parenthesis of this complement, then it will become x dash into y dash plus x and x dash into y dash plus y. Okay. So after simplifying this expression, so at the end we will get x into x nor y. So that is the answer. Okay, the exclusive NOR is the answer. Next one. After 3 calls of the function C function block below, the values of I and j will be dash. So here given int j equals to 1 and the bug function is open. So static int I equals to 0, int j equals to 0. So here I is a static variable. So memory assign compile time only. So its value increases 3 times and value of j will reset to 0 every time. So static can store the value of a particular variable. So now given int I equals to 0 and j equals to 0. Okay, so first in the first iteration, so here I will increase by 1. So I will increase by 1. So for the first iteration here they are calculating. So you have here they are given 3 calls of the C function. So for the first iteration, so 0 will increment by 1 value. Okay, and j will increment by 1 value. So now actually, so j must will become 1 and I must become 1. So here in the first iteration, the I will become 1. So I post increment and j post increment. So return the I value is 1. Now the I value is 1. So after the next iteration, that is second iteration, so here the I value is 1 and j value will again become 0. So for the previous function call, it is 1, right? But here static is not assigned for variable j. So that's why the I can store the value here and j cannot store the value. So now j will again become 0. Now I is incremented by 1 value and j is incremented by 1 value here. Right? So I will become 2 and j will become again 1. So j will become again 1. So now in the third iteration, so here the I value is now 2 and the j value is 1. So again for the third function call, so j will become 0 and I is 2. So post increment the value of I, that is it will become 3 and the j value is post incremented. So it will become again 1. Right. So after every function call, the j will become 0 and because of using the static variable for the I, so it can store the value. So final value of j is 1 only. Okay, and for I value of I is 3. So these are the final values. I and j values are 3, 1. Next one. Find the output of the following C code. So for the given program, so we are considering the x equals to 20 and y equals to 35. Okay, so here x equals to y plus 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 x plus plus. So x value is so x equals to y post increment, that means 35. So since it is post increment, we are incrementing the value but we are not writing the updated value, we are writing the old value plus x post increment. So what is the x value here? 20. So we are writing the 20 and incrementing the x value by 1. Similarly here we are writing the y value and incrementing the y value by 1. Now, so what is the x value here? Totally 55. So y equals to, so pre-increment y. So what is the y value here? 36, new value. So pre-increment, that means we have to increment the value and then write the value here. That is 37. Plus pre-increment x value. So what is the new x value here? X value is 55. So 55. So now y equals to 37 plus 55. That is y equals to 93. So this is the answer here. X equals to 55 and y equals to 93. The next one. The data hiding is taken care by. So what is meant by data hiding? Which will take care of the data hiding? Abstraction, encapsulation, modularity and inheritance. So from the given options, encapsulation is the concept that takes care of the data hiding. It involves building data and methods that operate on the data into a single unit, such as a class. And abstraction also means hiding. So here the abstraction deals with showing only the essential details and hiding the implementation complexity. But it doesn't focus on restricting access to data. Whereas the encapsulation will also restrict the access to the data. It hides the data and it also restricts the access to data. Okay, so that's why the answer is the encapsulation. Next, modularity. What is meant by modularity? So modularity refers to dividing a program into separate modules to improve the readability, maintainability and reusability of the program. And it is not related to the data hiding. Next, inheritance. Inheritance means inheriting the properties of the parent class by the child class. So it is also not involved in data hiding. So the option is the encapsulation. Next one. If a data item is declared as a protected access specifier, then it can be accessed as anywhere in the program, by the base and derived classes, only by base class, or only by derived class. So if a data item is declared as a protected access specifier, then it can be accessed by the base and derived classes. So that's why the option is B. Next one. So given a program here, a C program, so character pointer string equals to A, B, C, D, E. So a string pointer is pointing to this string A, B, C, D, E. So now we have to perform this operations, this printf operations here on that string A, B, C, D, E. Then what is the final output of the C code here? So here the string pointer is pointing to the starting of the string. So let us solve this printf functions here. So printf pointer to string. That means it will print the first element of the string, that is the A. Next one. Printf %c pointer to string post increment. That means it will first print the first element of string, then the pointer will increment. So it will print the first element of the string, and then the pointer will get incremented to the next value. Okay. So next. So printf %c string post increment to the pointer. That means it will print the first element, then pointer will increment. Okay. So it will print the first element. So what is the first element here? So B. So the string is pointing, the pointer is pointing to the B. So it will print the value B, and then it will increment. And then the pointer will increment. So it will increment to the next one. So now the string pointer will point to the next element. Now printf %s comma string. So it will print the element of the string. So what are the remaining element here? C, D, and E. So it will print C, D, and E. So answer is option C. An ER model diagram is a tool to represent each of the following options. So data model, process model, event model, or customer model. ER model is commonly formed to represent things that a business needs to remember in order to perform business. The ER model becomes an abstract data model that defines a data of information structure, typically a relational database. So here answer is the data model. So why answer is data model means it is used to ER diagram is used to visually represent the data and the relationship between the entities in a database. So it is a key tool in designing and understanding the structure of a database, which makes it a part of data modeling process. Whereas the process model focus on workflows or process in a system, that is the flowcharts or data flow diagram, etc. And event model, it focus on triggers and responses in a system, such as event-driven architecture. And customer model, a specific model that might deal with the customer data or behavior, but is not a general purpose tool like the ER diagram. So the answer is a data model. Next one. Which of the following tools is not required during system analysis phase of a system development lifecycle, SDLC? SDLC is a rapid application development which combines the prototyping, joint application development, and implementation of case tools. The advantages of rapid application development are speed, reduced cost, and user involvement in the development process. So here, reverse engineering tool is not related with the software development lifecycle. So the answer is option C. Okay, so here we have known about the RAG tool and reverse engineering tool, but what is about the CASE tool? That is a computer-aided software engineering tool. So these tools are widely used in the software development lifecycle in the case of the design and development, and they are not required in the system analysis phase. Okay, so that's why the option is reverse engineering tool. So this is not involved during the system analysis phase, but the remaining two, that is CASE tool and the RAD tool, are involved here. A black hole in a DFT is a hash. So actually there are three different types of holes, that is the three different types of situations may occur in the data flow diagram. That is a black hole, grey hole and the miracle. So what is in the black hole? Black hole means it has only input but there is no output. That is in the case of the black hole. The option B is correct here. And what about the grey hole? Grey hole means a processing step may have output that one greater than sum of its input is known as a grey hole. And what is meant by a miracle? A processing step may have output flows but there is no input flow. It is called as a miracle. So option B is the correct answer. Next one. Multi-value dependency among attributes is checked at which level? So multi-value dependency means it is checked at the fourth normal form. So option C is correct. Next one. A window into a portion of a database is a view. So a portion of database is viewed as a view here. A database view is a subset of the database sorted and displayed in a particular way. View is a logical portion of a database which is read by some users. A window into portion of a database view. Next, what is the time required to insert an element in a stack with linked implementation? So insertion into stack with a linked list implementation always at first node and deletion also at first node. So we need only arranging pointers in constant time. That is the big O of one time. So the answer is option B. Next one. Which of the following statement is false? About the trees, which of the following statement is false? A tree contains a cycle. So tree doesn't contain a cycle. A graph contains a cycle, but a tree contains a cycle is a false thing. So option B is the false, right? Every tree is a bipartite graph. This is correct. And every tree is a contains cycle is false. A tree with nodes contains n-1 edges. So it is correct. It is a connected graph. Correct. So option B is the correct answer. Next one. In the balanced binary tree given below, how many nodes will become unbalanced when a node is inserted as a child of the node G? We know that to know the balancing factor of a binary tree, so we have to subtract the height of left node minus height of right node. Okay, so here in the given graph, so we have to insert the child of the node G. So the child of node G must be inserted here, G, this one. So now let us calculate the balancing factor of each node here. So balancing factor of G is 1. So that is the left hand side nodes minus right hand side nodes, right? Balancing factor. So 1. Next for C. So C doesn't have any right hand side child, only left hand one. Left hand two nodes are there. So that is why the answer is 2 for the C. Next for balancing factor of B is 2. That is the left hand side is 2 and right hand side is 0. 2 minus 0 is 2. Next for E and F. So E is having only one child. Okay. Next for A, we have to calculate the balancing factor, that is the 2 minus 1. Right. So it has a 3 minus 2. So 3 left hand side there are 3 values and right hand side only 1. So 3 minus 1 is 2. Okay, so that's why the balancing factor is 2, which is it is not allowed here in the binary tree. Okay, so balancing factor must be 0 or 1, but this one is not allowed, so that's why. So here if you are inserting the node G, how many nodes will become unbalanced here? So here 3 nodes will become unbalanced. So A will become unbalanced, so B will become unbalanced, and C will also become unbalanced. Actually the balancing factor must be between -1, 0 or 1. Okay, so here 3 nodes are becoming unbalanced because of inserting the node G. So the option is 3. Correct option is 3. If the postfix form of a string is ABC plus minus D into, the actual string is dash. So we have to find out the postfix form of each and every option here. Okay, so let us find out the postfix of the option A. So what is the option A here? So A minus B plus C into D. That means first option A. So first we will evaluate this one. So ABC plus and minus will come out here. For the given question, we have to convert each option into postfix form. So starting with A, the first one. So we will start from the center point here, that is the B plus C. Right? So we can write the B plus C as a BC plus. In the postfix form, the operator will come at the end and operand will come first. So BC plus next minus A and then B and then the operator in the multiplication. Okay, so this one is matching with the given question, right? So the answer is A. So let us check out the remaining also. So if we check the remaining also, so the answer won't match with this. So let us take the option B. So first we will write from the center part, A minus B, right? So AB minus, next C plus C, right? That means C plus. So AB minus C plus and into D. So postfix means, so first the operand will come and then operator will come. Right? So this is not matching with the given option. So the answer is yes. Right. Next one. The algorithm that will efficiently sort an array that is nearly sorted except for the interchange of some adjacent pairs of numbers like 1, 3, 2, 5, 4, 6 is. Bubble sort will take big O of n time when array is already sorted. Since given array is almost sorted, so other sorting algorithm give big O of n log n as best case. So the answer is bubble sort. So this is all questions covered in the part 1, 25 questions. First 25 questions covered in the part 1. So for the remaining 25 questions, watch the part 2 video. Thanks for watching.